Ever wondered how AI seems to just get it? You ask it to write a story, and it doesn't just copy and paste from the internet. It feels like it actually thought about it. But here's the wild part. Even the engineers who built these complex systems don't fully understand why they make certain creative choices. Welcome to the black box of neural networks, the engine driving the future of human-like intelligence. Let's break down what a neural network actually is. Imagine your brain. It's packed with about 86 billion neurons, all firing and connecting to help you think, learn, and live. AI models, like the ones you use every day, have something similar, but they're called parameters. Think of them as digital neurons. While they aren't exactly the same, they operate on a fundamental principle called weights and biases. This is the secret sauce that allows AI to learn and make decisions, much like our own brains do. It's all about pattern recognition. So how does this actually work in a way we can understand? Let's use the apple test. How does a baby learn to identify an apple? You don't hand them a 500-page encyclopedia on fruit. You just show them an apple. Their brain sees red, round, and has a stem. It quickly processes these features and concludes, that's an apple. This is a simple neural network in action right inside our heads. AI learns in a very similar way. The first layer, the input layer, might see the color red. The second layer, the processing layer, starts asking questions. Is it a ball? No, it has a stem. Is it a cherry? No, it's way too big. Finally, the third layer, the output layer, confidently declares, that's an apple. By being shown millions of images of apples and things that aren't apples, the AI network adjusts its internal weights to become incredibly accurate at identifying them. It learns from experience, just like we do. This brings us to why AI can think so much like us. It's all about pattern recognition. Think about it. You can recognize your mom's voice in a crowded, noisy room because your brain has learned her specific vocal frequency. It has weighted her voice as more important than all the background noise. Your brain is a master at filtering and prioritizing information based on past experiences. AI does the exact same thing, but with data. It can detect sarcasm in a text message because it has analyzed millions of examples where the words used don't quite match the intended meaning. It's seen the pattern of sarcasm so many times that it can recognize it almost instantly. This ability to understand nuance is what makes modern AI feel so uncannily human. It's not just processing words, it's understanding the context and sentiment behind them. And this is where things are about to get even more interesting. Let's talk about the 2026 twist, multimodal learning. Right now, most AI interacts with the world through text. But in the very near future, AI won't just read. It will see video, hear your tone of voice, and even understand gestures. It will process information from multiple senses at once, creating neural pathways that are far more similar to a human's sensory experience than ever before. Imagine an AI that doesn't just read a script but watches the actor's performance, listens to the emotion in their voice, and understands the story on a much deeper, more human level. This isn't science fiction. It's the next step in the evolution of AI. Now, for a truly mind-blowing concept, AI hallucinations. You've probably heard about instances where AI makes things up or gives completely wrong answers. We often call this a bug or a failure. But what if it's something more? What if when an AI hallucinates, it's actually the digital equivalent of a human dream? Think about it. When you dream, your brain is connecting random thoughts and memories, trying to find patterns and make sense of your day. Sometimes it creates bizarre and illogical scenarios. An AI hallucination is remarkably similar. The model is trying so hard to find a pattern in the data and provide an answer that it starts inventing connections that aren't really there. It's not necessarily a bug. It's a sign that the AI is engaging in a form of creative, abstract thinking. It's pushing the boundaries of its knowledge, just like our brains do when we're asleep and dreaming. This flaw might actually be a feature, a glimpse into the AI's capacity for imagination. So why are neural networks the key to the future of human-like intelligence? Because they don't just compute, they learn, they adapt, and they even dream in their own digital way. They are designed to mirror the very structure of our own brains. As we continue to build more complex models and feed them richer, multimodal data, the line between artificial and human intelligence will only continue to blur. We're not just building better calculators. We're creating systems that can understand, create, and interact with the world in ways that were once thought impossible. The black box is still a mystery, but it's a mystery that holds the promise of a future where technology understands us better than ever before. So, what exactly is a neural network? Forget the complex jargon for a second. Imagine a digital brain, a web of interconnected nodes, or neurons, that learn from data in a way that's inspired by our own human brains. It's not about programming a machine with a rigid set of rules. Instead, It's about giving it the ability to learn, adapt, and make decisions on its own. Well, think about how a child learns to recognize a cat. You don't give them a textbook definition. They see lots of different cats, big ones, small ones, fluffy ones, striped ones, and over time, their brain just gets it. Neural networks work in a very similar way. They're fed massive amounts of data, like millions of cat pictures, and through a process called training, they learn to identify the patterns and features that define a cat. This is a huge leap from old school AI. Traditional AI was great at tasks with clear, logical rules, like playing chess. It followed a script, but it struggled with ambiguity, with the messy, unpredictable nature of the real world. Ask a traditional AI to tell the difference between a muffin and a chihuahua, and you might get some hilarious but wrong answers. Neural networks, on the other hand, excel at this kind of pattern recognition. This ability is unlocking incredible possibilities. Now let's talk about some real-world examples that are already here. In healthcare, neural networks are analyzing medical images like X-rays and MRIs with a level of accuracy that can sometimes surpass human radiologists. They can spot signs of diseases earlier and more consistently, potentially saving countless lives. This isn't about replacing doctors. It's about giving them powerful tools to do their jobs even better. Then there's the world of creative arts. AI-powered tools built on neural networks can now generate stunning images from a simple text description. They can compose music that's emotionally resonant and even help write scripts or poetry. This technology is acting as a new kind of creative partner, a muse that can help us overcome creative blocks and explore ideas we never thought possible. And of course, we can't forget self-driving cars. For a car to navigate a busy street safely, it needs to understand its environment in real time. It has to identify pedestrians, other vehicles, traffic lights, and road signs, and predict what they'll do next. This is an incredibly complex task that relies heavily on deep neural networks processing a constant stream of data from cameras and sensors. But how do they actually learn? The process is fascinating. It's all about trial and error on a massive scale. During training, the network makes a guess, say, "This image is a cat." Then it checks its guess against the correct answer. If it's wrong, it adjusts the connections between its digital neurons, ever so slightly, to improve its chances of getting it right the next time. Repeat this process millions or even billions of times, and the network becomes incredibly proficient. This learning capability is what makes neural networks so powerful and so human-like. They can understand context and nuance. Think about language translation. Old translation tools would often give you literal, word-for-word translations that sounded clunky and missed the meaning. Modern translation services, powered by neural networks, can understand the entire sentence, the idioms, and the cultural context to provide a much more natural and accurate translation. They've learned the feel of a language, not just its dictionary. So, what does the future hold? The potential is mind-boggling. We're moving towards what's called artificial general intelligence, or AGI. This is the idea of an AI that can understand, learn, and apply its intelligence to solve any problem, much like a human being. While we're not there yet, neural networks are the most promising path to get us there. Imagine an AI that can help us solve some of humanity's biggest challenges: climate change, disease, resource scarcity. By processing vast data sets and identifying patterns that are invisible to the human mind, these advanced neural networks could propose novel solutions and accelerate scientific discovery at an unprecedented rate. Of course, with great power comes great responsibility. As we develop these technologies, it's crucial that we have conversations about ethics, bias in data, and ensuring that AI is developed for the benefit of all humanity. It's a journey we're all on together, and understanding the core technology is the first step. Neural networks are more than just a clever piece of code. They are a new paradigm for intelligence. They represent a shift from telling machines what to do to empowering them to learn for themselves. They are the digital brains that will power the next wave of innovation, making our world smarter, more efficient, and more connected. They are, without a doubt, the future of human-like intelligence. Thanks so much for watching. If you found this deep dive into neural networks interesting, please hit that like button and subscribe for more content decoding the future of technology. Let me know in the comments what part of AI you'd like me to explore next. See you in the next video.